So first, thanks to Bobby, to Sophie, to all the organizers, to ADC, and I'm not going to name them all, but to all 25 or so sponsors of the conference. It has been a fantastic event. Hopefully, the next up to an hour will be light but interesting. So I'm going to talk about commercialization of audio technology, my own personal perspective dealing with 4 startup companies that I've been involved in. So a rough outline of the talk is as follows. It'll kind of jump back and forth between the story of what happened with each of these companies, Lander, Waveshaper, Roex, and Nemesindo, and some lessons learned, some advice, some interesting anecdotes about each of them. So a bit more background. I'm a professor at Queen Mary University of London. If you had met me when I was 10 years old and asked me what I wanted to do when I grow up, I would have said scientist. So I never thought of myself as starting companies. But working in the audio space, a lot of things have, as you know, practical application. And so things and opportunities came to me because of that. I really didn't know what I was doing in the beginning. Hopefully, I know a little bit about it now. So it started with a PhD proposal. There was a PhD student, so way back in the day when I was a young lecturer at the university, one of, if not my first, maybe a second PhD student working with me, started working on analog to digital converters for audio, and came to me one day and said, I want to switch my PhD topic, to which I was thinking, oh no, this is going to be a problem. And he suggested the idea of blind mixing for live audio. In other words, could a computer listen to all of the incoming audio sources during a live performance, analyze them, and use best practices in music production to determine how to mix that content? And my contribution at the time was simply just telling him, this is a great idea. And so the first results we had were on acoustic feedback prevention. So the idea is most feedback prevention systems are really like feedback cancellation. Identifies whether there is or should be feedback and applies notches in the spectrum to try and remove that feedback and prevent the howl you get when someone approaches a microphone. And we decided, could we have a system that instead learns whether feedback is possible and corrects it, adjusts the system in advance? So it's addressing the symptoms rather than the results. And when we first published the research, I got picked up in the popular press and all sorts of things. One of the articles right in the middle, that's former member of Jesus and Mary chain saying, how dare these people ruin feedback in our music? And they loved it. And not for this, but for something that happened later on when I mentioned that there were 2 people fighting, literally fighting, at a conference over some research that I was involved in. Someone else said to me, oh, that's great, you've made it. If people fight over the work, that's a good sign. So at this point, I realized, keeping in mind, I was still a young academic. I knew I wanted to do research. I had an interest in these things, but I didn't know which direction to go. You know, how do you build a career when you just know you want to build a career doing research? But there was a bit of sort of follow the money. In this case, it was not money, but follow where the impact is. So started building a team around this. When students came to me saying they wanted a master's project, I said, well, there's aspects of this mixing problem, aspects of music production that we don't understand. There are gaps in our knowledge of what the best practices are in sound production. So let's do some experiments. Would you like to work on this, work on that? And different researchers, very talented researchers, some of whom went on to have successful careers with some of the companies who are represented here today, all worked on different projects in this field of understanding music production and specifically the mixing and what the mixing engineer does, and from a very technical perspective as well as from a very perceptual perspective. So I'm going to play a video for you in a few seconds. Hopefully the sound will be on. If it sounds terrible, that's because it's supposed to. What we have is some sources coming into an automatic mixing system, and all the levels are off, and there's been no production applied. And during the video, we'll simply turn on automatic mixing tools that were developed by the researchers working with me, and you'll hear how the audio changes. Hopefully, it will be self-explanatory. So bear with me. So you get the idea. That's how it works. We have some understanding of what are the rules for how the levels should be set for different sources, depending on the characteristics of those sources, how they should be panned, how equalization should be applied. For those aspects that we had very little knowledge of, we did additional perceptual studies to try and understand it. I remember one time presenting this work at an AES convention, and if you haven't been to those conventions, the industry talks are usually very well attended, but the esoteric academic talks, the room is half empty. In this case, I was giving a talk on this research, and the room it was in had glass windows all around. It was in the middle of the convention center, and I could see all these faces pressed up against the windows, and the room was packed. Because they all wanted to find out about this idea of automatic mixing. Today, I don't think it would be much of a shock at all. But at the time, that's when I started to realize, hey, this is unusual. People are not familiar with this, and they're interested. So there's this idea, if you haven't heard it before, of disruptive innovations. The idea is that certain technologies come around, and there's an entrenched technology. There's a standard way of doing things. Think of the automobile when everyone's riding horses. The entrenched one is very well established and very high quality. But with sufficient effort, investment, and resources, the disruptive one can overtake it and change the way people can do things. And so there's a potential that the idea of intelligent systems automating or assisting in certain aspects of the music production process might be a disruptive innovation. So some of you will know this sort of thing very, very well, but there might be a few people in the room that this is new to. With high-tech spin-outs or any sort of startup company, there's always what's known as the elevator pitch. And the idea there is that if you are in the lift with someone and it turns out that someone is a wealthy investor, then you have until it gets to whatever floor that investor is on. Don't press the button for one floor. Go as far as you can with that person for you to pitch the idea while they are stuck and have to listen to you. And hopefully your pitch is good enough that they will invest. I actually know one person this happened to. They weren't in the lift with someone. Rather, they were in the queue to get a coffee at a coffee shop, and the investor was right behind them in the queue. So they did the elevator pitch. So this is the elevator pitch that we put together for automatic mixing. And keep in mind, this was quite a few years ago. So the modern digital camera has a wide range of intelligent technologies to make its use much easier for the user, for the everyday person. These include things like autofocus, face, scene, and motion detection, red eye removal. In contrast, the modern digital audio console or audio recorder has none of that. It has no intelligent features. It requires a professional for use. It's very complicated, and hence quality often suffers. So there's no autofocus for audio, and that's what we're trying to provide. And this worked as a pitch because people can get this, and everyone at the time had some form of digital camera. The only difference now is everyone has that embedded in their phone. And I think the pitch still works in some variation. You all know that there are intelligent features now, but still the audio technology is massively complicated compared to equivalent image technology. There's reasons why the analogy here can be argued, but the point is it gets the idea of the company across very easily. I had an interesting conversation with an investor one time who just didn't get the idea that hobbyists would spend a lot on their music technology equipment. And it was perfect because I looked at the guy and he was obviously a serious runner and had some very expensive trainers on. And I said, well, you spend a lot on those shoes, right, for your hobby? So it's the same thing for people interested in music. So we were going around, we were sort of pitching the technology to companies because companies had already told us that they were very interested. We even reached the point where we were talking to, here's an example. So we were contacted by the director of new products at a big mixing console company, and they said they read an article about the work, and they wanted to see if there was a way that they could find some commercial application. So, yeah, that is the letter everyone wants about their product or their technology, whatever it might be. But I mentioned the work started with a student, Enrique Perez Gonzalez, and he moved on. Right when we were talking to this company, and the company was getting to the point where they're talking terms and conditions with an agreement with, to license our product, Enrique says, hey, I just got offered a job at one of the world's biggest mixing console manufacturers. So as an academic, you're faced with this challenge, which is no matter how much you try to stop it from happening, those students keep graduating. I try, and they get jobs in the industry. And so, obviously it's a good thing for them, and it is what it's all about. But in terms of commercializing the technology, we reached a little bit of an impasse. I got some support from the university, recruited a master's student to help take on the technology, and we were able to promote it again. So now we have a technology that we know has commercial potential, but we don't have anyone lined up. And then a venture fund came around, and they have an interesting business model. So this venture fund, they realized that university tech transfer offices, most of them are not very good. They don't always know what they're doing, and yet they're sitting on tremendously high-quality IP. So the venture fund, Tandem Launch, they try to partner with university tech transfer offices to say, hey, let us acquire or license the IP, and you get a stake, and we will create a company from that IP, and we will try to get the players in the market interested in acquire the company or the technology behind the company or so on. As it turned out, their business model didn't work as they expected because some of the companies that they were trying to sell on to the big players started making money right from the get-go and were being successful. They didn't need to be sold on. But anyway, that's their business model. So they were doing a sort of European tour. They're Montreal-based, and they were talent scouting the universities the same way Premier League football teams would talent scout the lower leagues. So they came to the university where I work, and I tagged along while a whole bunch of technologies were being pitched to them, and they got interested in what we had, which was great, but there's a big gap between proof of concept, which I think is what we had, and prototype, which is really what industry need to take it to the next level. It's equivalent to you have a great bit of audio technology and it sounds good, and it's based on wonderful research and it's novel, but often the software engineering and interface design and everything else, even though it's not technically research, it's more effort and more challenging very often than the core, wonderful, innovative audio that it's all built around. So that's the sort of thing we were missing. So we needed to build demonstrators. And it wasn't one single piece of technology. It was a whole range of tools to try and do some sort of intelligent mix. This meant, and I have to mention this given where we are, this meant we had to build VST plugins, we had to understand JUICE and C++ programming, and we started building a whole range of VST plugins, and just to show off what we had, just so that we could show things to the investor and potential investors. At this point, by the way, we were beginning to work directly with Tandem Launch, going through the various stages for them to fully, properly invest. We did run into a problem. I remember the email specifically started with, "We have a slight hiccup." And this was because the investor at Tandem Launch was based in Montreal, but I'd received grant funding from Royal Academy of Engineering over here, and that funding was conditional on us founding a UK company, and the investor needed a Canadian company for their tax purposes. So we made two companies. At a much later stage, they merged together. So at that point, we had full-on investment. A second investor came in based on what Tandem Launch had done, and the company really started to take off. So one surprising thing that happened, and this often happens with investment, with technologies, is it pivoted. So you think it's going to be one thing, you come up with a pitch about something, and sometimes it's because it doesn't work. In our case, it was different reasons. It changes into something different. And there's a balance that needs to be found between accepting that your technology will have applications or market or something different than what you planned for, sometimes even than what you dreamed for, a balance between that and between the fact that you do have a dream. You do have some idea that, this is what it's all about. And investors can sometimes come along and say, you created X, but really we want you to do Y. You might know things better than them, or you might just say, that's not what I want. So this wasn't that, but what happened is we had this technology built around mixing. And I remember one time going to Lando's office. It was still called, at the time, Mix Genius. And they demoed their system on some audio tracks. It was all based on the technology we provided. And it was such a wonderful moment, the thing that myself and others have been working on for a while now, and suddenly hearing it in a commercial setting. And the audio went from the bad to the amazing with just a couple clicks of buttons. But that's not what they commercialized. Instead, they commercialized automatic mastering, partly because it was the first thing that they brought to market. And when it started taking off, the idea of mixing was always postponed for a while until it was just off the radar. And the mastering is very, very effective. There's also some technical reasons. So, for instance, VST does actually support multi-track plugins. It's possible to write a multi-track VST plugin where the sources aren't just multi-channel, but the incoming sources are guitar, bass, drums, and vocals, or what have you. But most of the DAWs do not support multi-track plugins. Even some of the ones that you would expect to, given where VST came from, do not fully support that. So, that's not actually a criticism. They weren't thinking of me in advance when they built their DAWs. And there are hacks to get around it, but then it's different hacks for different DAWs, and ultimately it's still a hack. So there's technical software engineering reasons why mastering was much easier at the time. Anyway, it really, really took off. Lander is now a major player. At one point, they were doing more mastering than all of the mastering houses combined in North America. A large valuation, over 3 million users of the service. You can argue about aspects of it. The sound quality in the beginning, I think, wasn't that great. It has improved over time. But it's clear, no matter what one thinks of Lander, it is clearly a success story. And it's based on an audio technology that was sort of an idea in the beginning and just went up. And it helped my career. You know, I'm not living on a yacht, but it did advance me as an academic. The university respect what happened, and it's sort of a success story from the university. So that's the first of these 4 startups. The next one, I don't know, you people who have been in the field for a while, I said you people like it's offensive or something, but people who have been in the field for a while might have noticed something that changed around 2016 to 18. There was a type of machine learning that was very rarely used because it wasn't very good, dealing with neural networks and deep learning. And it revolutionized everything in machine learning, partly because you work on a standard classification problem, and all these other techniques might get 85, 88%, and then the deep learning one gets 93%. And that's happened on problem after problem after problem. There's many more reasons. So another researcher working with me came to me at the time. Well, we were working together. I knew I was promoting things within this general field of music production, and he wanted to try this deep learning stuff that was starting to gain a little bit of popularity. And he did great research, and his name's Marco Martinez, and then he graduated, and around this time, I'll talk about it in a few minutes, I was putting a lot of my own time and effort into procedural audio and trying to take the procedural audio work that we were doing to a very high level, get it from proof of concept to prototype. And the previous investor, we had quite a good relationship with them. They contacted us and said, hey, we heard about a technology coming from your group. We're interested, let's have a discussion about it. And so I said to them, this is the procedural audio stuff we're working on, right? They said, yes. I said, great, let's have a talk. And I prepared some videos and, an elevator pitch and all of that stuff. And when I started talking to them, I realized they were talking about Marco Martinez's PhD research on deep learning. So I was very annoyed, but on the other hand, it was great news. Marco, by the way, although he moved on, was very happy about this, and he's got his name on the patent and has a small stake in the company. So these people move on, but they don't get forgotten, and if possible, they remain part of it or at least compensated. So anyway, based on Marco's work, the venture fund invested. They brought in their own tech person, someone not from the audio field, but with a lot of knowledge of deep learning, and a business person who didn't work out, so they replaced and got another. And it started off as Tones. It's now Waveshaper. And they originally started applying deep learning to music processing tasks, like analog equipment emulation, which was a big part of Marco's PhD. Now, they do more general real-time neural signal processing, especially audio signal processing, but not specifically music. So I'll give you an example of something that they did, which is just emulation of an analog overdrive. Here's unprocessed. And so I don't have the original analog equipment, but this is the neural network emulation of it that they produced. So what's happening with Waveshaper? They had a lot of hiccups in the beginning. I mentioned one of the two people brought in to sort of start the venture. It didn't work out. They had to bring in another, and I think they went through 2 more before they found the right team. And they've now have a small team, a couple of contracts, and so bumpy ride in the beginning, but definitely growing at the moment. I talked a bit about pivoting already, but there's also the idea that the investors, if they're investing in any sort of high-tech work, like what all of you do, they usually look for 2 people at a minimum. They very, very rarely invest in an individual, even if the individual hypothetically has all of the qualities that you're looking for. When I say very, very rarely, I can think of at least one exception that's been here today. But they tend to want a tech person and a business person as the partners. So, if there's one individual who is the tech person but doesn't have the business experience, they know that it should be there. And that's a big factor. And oftentimes when I talk to potential investors, they say, interested, but the team, you need someone else in the team. It's a big factor. So that was quite an issue with Waveshaper in the beginning. It started off looking like it was the right team. It wasn't. Luckily, the investor kept with it until they found the right balance. So that is startup number 2. But as I mentioned earlier, Lander never commercialized automatic mixing. They worked on mastering, and they did wonderful things to it. But as a research group, and this was in the agreements, we still had the ability to research different approaches to automatic mixing, to music production, to everything around that. There was no conflict there. And the approach taken by Lander certainly was not the only approach, not even necessarily the best approach. So, it wasn't. So along came another PhD student, Dave Ronan, and I had mentioned Lander was the initial technology that went into it. The technology that's used in their mastering system is their own new thing, but the initial technology is kind of based on, let's try to understand all the different rules that sound engineers do. How do they do the level balancing? How do they do the EQ? How do they do the compressor? Each one a separate rule, and let's put all of those rules into the system. It was quite an intelligent system because it doesn't apply them as presets. It analyzes the signal to determine how to apply each rule, but still each rule is separate. Dave Ronan, as part of his PhD, looked at it very holistically. What does the sound engineer do? Not how do they adjust the threshold and attack and release on a compressor, but what are they trying to achieve? And that end goal, can that be reached by an AI system? Would it do it differently? Would it do it better? And in some ways, that's a far more elegant approach. We don't need to build 20 tools. We need to build an intelligent system that arrives at the right result at the end. And so that led to the formation of ROEX, formed last year in 2022. ROEX because of Dave Ronan, and also ROEX is a type of auditory filter. And the company is moving fast. So it achieved investment. And this is also a counterexample because they invested primarily for one person needing it, but Dave had the support of myself, of the university, and others, but still one person needing it. That's rare. And it got a couple of grants, lots of support from the university, and so on. And it has an online service that I'm going to show you a little bit of it in a minute, and some commercial contracts. So why did they invest in this? There are 3 things, an investor told me this, 3 things that they generally look for. People love to say there are 3 things. They never say there are 7 things or there are 2. It always has to be 3. Team, tech, and market. And in this one, it was for them an easy yes, yes, yes on all three. So you need to know that there's a market for it. You might have the most genius technology, but no one wants to buy it. You need a technology. If you have something that everyone wants, so what if everyone else has that? Or everyone else could have that same thing in a few days' time if they look. If you have some novel or significant technology, then you have some sort of first mover advantage, or at least you know that it's going to be challenging for others to develop the same technology, or if there is some competition, it's relatively small. And so the technology needs to be significant. Now, of course, there are startups in the non-tech space where that's not what it's about, but it's also almost self-evident. A tech startup needs special tech. And the team itself, where usually they look for, at a minimum, some combination of business expertise, and that could be, just experience with startups, or it could be very specific knowledge about this marketplace. Someone who is in the team who, say, has a 10-year track record in the audio industry, in senior management, and so on. And the team where they really trust their technology and they're smart and they're dynamic and so on. And I've seen people here today, people presenting on this stage earlier today who clearly had that. And that was why a company was very interested. They often say, and it's partly true, that they invest in the person, not the technology. Now, they wouldn't invest in the person unless they know that person is capable of the technology, but it's a big factor. If the technology isn't quite right, but they trust the team, they're probably more likely to invest than if it's the other way around. The technology is great, but they're unsure about the people. So let's see if I can play you a short video. This is a sort of before and after Roex's automatic mix.
Everybody keeps telling me I should get a lobotomy, but I keep telling them that lobotomies don't grow in fucking trees. Everybody keeps telling me I should...
So that gives you an idea. They have an online service, quite a lot of users, positive feedback. It's been a smooth journey so far. That doesn't mean it's not challenging. It can be smooth, but it's still a tremendous amount of work to get something from technically we've got something to developed to the point that it could be product, to getting it out in the market. And this is something people always underestimate, just how much you have to push with something in the market. So I often now have to talk to people who are starting on this commercialization, this entrepreneurship journey. And what I sometimes see is people who are hardworking, intelligent, dynamic, and everything else, but they assume that I've got something great, I'll put it out there, put up a website, speak to a few friends, and people will just start buying. And if that is the case, that's wonderful, but usually you have to push, at least in the early stages, to start building up awareness of a product. So yeah, that is Roex. I've got one more to talk about before general ideas, and it's a different route to commercialization. So I mentioned this tech team market. Another way of looking at things, essential ingredients, you need some sort of game-changing idea. If you want to get investors, want to get people excited, you need to be excited yourself about it, and hopefully you can be excited if you think if you genuinely believe this is incredible. And you need very talented people. And of course, another thing that people often forget, you need to actually build the thing. It's not enough to say, imagine this could change the world. But if you don't have something to show, of course, it won't go anywhere. At some point, you need to demo to investors, to licensees, to customers, and so on. And there were sort of maybe 3 levels of that initial demo when you're trying to get people interested. There's the one where you have videos that you can show them, and they're sort of mock-ups, and there's something that you've developed, but they're seeing a recording of it. There's the one which has worked for me, where you demonstrate something from your own laptop with your headphones, set up your way, using the audio files that you pre-prepared, partly because you know that if you try it anything different, the whole system is going to crash and you'll get all sorts of errors and things like that. But if you press the buttons in the right sequence, it looks pretty good. And there's the third, which is you're able to say, hey, this is the demo, take it home, try it out, tell me what you think tomorrow. You don't need to be in the room to them. You don't need to offer them a lot of instruction. It's risky. When I've done that, I've said, there's a chance I haven't been able to break the thing, but because I'm giving it to you, I'm sure you will find a way to do it. So that actually build the thing, there's various levels of it. But of course, if you are seeking investment, the more you can show them that this is legit, and the more that they can be wowed in that first pitch, the more likely you are to get the investment. We've also had, we found out a lot about product and technology when we've done these pitches. I remember one time talking with a potential investor who knows nothing about audio, but he had very, very big pockets. And so we were quite intimidated talking to him. And we were playing automatic mixing technology, and we turn on the level stuff, and he's listening over headphones, turn on this, turn on that. And then we turn on the automatic stereo panning, and his eyes lit up, and he's going, wow. And it's just, that wasn't to cheat because it was automatic, but still his eyes lit up because he heard the difference between mono and stereo, not because he was admiring the technological innovation. So I mentioned there's one more idea, different route to commercialization. Not just a different route to commercialization, but this is not a music-specific technology. So here's the elevator pitch. Digital video effects have reached an incredibly high level of realism, so much so that they are almost indistinguishable from the real thing. In contrast, sound effects are sourced one of 2 ways, either Foley, essentially banging pots and pans together and sticking a microphone next to it. It can be creative, really interesting, but it's impractical for a lot of uses. It's very expensive, and not everyone can achieve it. Far more likely is the use of sample libraries, simply hundreds of thousands of pre-recorded sounds. If you need the sound of thunder for a scene, somebody somewhere has recorded something a bit like the thunder that you want. This offers very little control over the samples. It's uncreative, repetitive sounds. Everyone walking in a game is going to sound the same unless you use hundreds of different samples. Lots of limitations on this. It's the equivalent, and I always jump back to these video analogies, partly because they're so easy. It's the equivalent of if you needed some special video effects, you simply go through a photo album and find the 1,000 photos that are closest to what you want and put them into a scene for the effect. So we don't want to work that way. An alternative is procedural audio, where sounds are generated by an algorithm. It's like working with recipes rather than ready meals. This allows someone, everyone's familiar with this, synths can generate all sorts of sounds. So you have an algorithm doing what a really talented sound designer might do with a synth. You can create any sound effect this way. You need the sound of a dragon roaring. No one's ever actually recorded a dragon, to my knowledge, but you can have systems that generate those sounds based on an understanding of the lengths of the vocal cords in a dragon and the gases inside their throat, and however one wants to approach it. hence new sonic experiences. There's a benefit for games of no stored samples, potentially high audio quality. You can control these things. If you have the sounds of footsteps, you can adjust the speed at which someone walks, the type of surface that they're walking on, and so on. So here, we didn't have an investor. I spoke to loads of investors and always got kind of this frustrating close of, well, talk to us once you have some traction in the market. And of course, to get the traction in the market, we need the investment so that we can put the effort into it and move forward. Talk to us once you have a licensing deal and so on, or not quite for us and things. So we did get some funding from Epic, who they fund a lot of R&D, and we pitched the idea of procedural audio in the Unreal game engine, and we've been using that relatively small amount of funding to do what's known as bootstrapping, which is just basically starting a company without investment. Hopefully you sell a little product or get a little funding to do enough to get to the next stage, get to the next stage. It is hard, much, much harder than investment, because you or the small team have to do everything. Imagine if, for any of you, there are many, by the way, I've spoken to quite a few people, many people here who are sort of independent consultants or contractors as software engineers. But imagine if you had to do the payroll, the HR department for a small team. You had to do all the marketing, all the branding. You had to do the GUI work and the audio DSP. Even if you can outsource some of it, it still, has to be a very small number of people doing this for everyone. So it's harder. But here's kind of what the company is about. And like the other videos and audio, it should be self-explanatory. If I can figure out how to play it. Okay, so all of the sounds in that video were procedurally generated, algorithmically generated, except for the music. I suppose I really should have used one of the music generation services that were that people here have developed. But an interesting thing also, none of that is deep learning. So we did use deep learning and some machine learning to optimize and improve some of the models, but they're all sort of algorithmic, dealing with sinusoids and oscillators of other kinds and modulators and putting them together to have an algorithm, sometimes a little bit of physical modeling in there, but still an algorithm generating the sound. And the reason why we did it that way is because we want the sort of controllers that the sound designers want. You want to be able to adjust the crack and the rumble in the thunder. And there's, in theory, doable to find those controls with enough training data, with a deep learning model, and with sufficient annotation of the training data so that you can then sort of interpolate, you can generate controls for the extremes of thunder, no rumble, thunder, lots of rumble. In theory, you can, but it's definitely not ready yet. So no deep learning in there. But so we haven't found investment yet, still looking, and it's a big challenge. If you are an independent software developer, and it might be absolutely fine. But if you're trying to sort of break through with a different technology, the sort of thing where you really need to convince people about it a lot, it's a huge challenge. And I've learned a lot from some of the talks today and yesterday about it, but I'll still maintain how difficult it is. However, I'm not saying don't do it. It's a different approach, and there are many, many different approaches that can work with commercialization of audio technology and with entrepreneurship. So, before I talk about some of the approaches, let me talk about some of the challenges. And I, as an academic, look at the challenges of trying to take technology out of academia and put it into industry. But some of these challenges apply in any case too. If you have audio technology that you've worked on as a hobbyist, or just as part of the open source development community, or via some hack days and things, many of these challenges still apply. So academia is about high-risk research with unknown outcomes. If, say, you can argue that neural networks can be used for audio processing in real time, and I know how to do it, and people are interested, no one would fund that as academic research. What you need is a technology where we think this might work. There has to be some research to do. It might fail. It's risky, but if it works out, then there's big interest in it. So what gets funded in academia is partly because it's not quite at an industry stage. Industry, on the other hand, they want to address real-world problems with some certainty of the solution. It doesn't need to be definitely certain, but the risk needs to be a very, very managed risk. Academia, they want new ideas and knowledge. Why does this work? Why is not important in industry, not directly. They want to know that people are interested. They want to know that it solves a problem in the market. The why of that, less interest. As mentioned before, academia tends to start with proof of concept. We've shown that this could work. Now, industry, go do something with it. Industry stuff, that's not quite sufficient. There needs to be some sort of prototype, some demo that shows it can go out of the lab in some significant sense, and then they're willing to take it up from there. So there's often a gap. Sometimes you can get lucky and industry are already interested, but usually there's a bridge to be crossed. This applies to the whole open source movement as well. It's about sharing the knowledge. It's tell the world what you're doing, publish it. Industry, they want to protect the IP, and it's about patenting. Now, there's an important point here, and it did come up in the answers to one of the questions on the panel talk with the legal people. I forget what it was called, and apologies. But so I'll give an example. I knew someone who had an amazing pitch correction a long time ago. And they knew that theirs was better than just about anything in the state of the art back then. So they didn't tell anybody how it worked. They kept the thing a deep trade secret while they were going around to the trade shows, NAMM and Music Messe and AES and things, trying to get the companies interested. And they were, but it didn't quite work out commercially. Maybe people weren't quite ready then, who knows what. But Then that person tried to, say, get research grants to develop the work further. And I tried to collaborate with him. And I said, OK, send me your CV. And it was like a blank page for the last 3 years because he hadn't been working with anyone. He hadn't told anyone. He just said, you know, I've got a great thing. Listen to this demo. Now, so there were problems with his approach. He was protecting the idea so much and keeping it all as such a trade secret that not enough people knew what he was doing to get the interest. With certain things, you've got a magic chemical formula that treats cancer. You probably don't want to tell anyone about that. But an alternative approach, especially in something like audio, is tell a lot of people. There's a point where it's risky, but tell a lot of people, maybe even hint at what's under the hood to get them interested. I remember with one company I was involved in, the CEO at the time phones me up, and this was still early days of the company, and he's like, George, why did you present this at a conference? You shouldn't have done that. Now we can't patent it. It's all been disclosed. And I said to him, don't you remember? You were in the audience when I presented that. That's why you got interested in the first place. The ideal approach is generally, and again, it depends on what you're doing and everything, but very often, try to patent at an early stage. Try to protect the IP at an early stage. Then you can talk about it. Patenting is essentially disclosing. It's telling people what you've done, but then you have ownership of the idea. There's a lot more to this, but my caution is that I've seen people who are too secretive in this field. And that can be a problem because you need to promote, you need to get the interest. And of course, academia, it's all about spending the money. You get that grant and you spend it to do wonderful things. Industry is generally about generating revenue. So when people first got interested in Lander, I didn't know what to do about it. There was a point when people were talking about equity stakes and what's one of the acronyms, EBITDA and things. I had no idea what they were doing. But as an academic, I thought, right, what do I do? So I went to the library, I browsed the shelves, I read the books on entrepreneurship. There is a book called The Founder's Dilemma, which was absolutely brilliant, and I would recommend this to anyone. It's not the sort of self-help book. It's a bit more technical and research-based than that, but still a very clear read on what to do when starting a company. And here's sort of the types of questions and how, in the examples I gave, they were approached. Should you start a company? Most of the time, yes. But it's not the only thing to do. Technology can be licensed directly. It can just be gifted to the community. It's what you want, and it's what you can do, and what is appropriate for the technology. Who are the co-founders? In the cases of the companies I thought about, university students, an incubator or early stage investor, everyone involved in the beginning. It's not a small group necessarily. When one reaches the stage of trying to exit the company, and I did ask the legal people about this earlier today, then it's often quite important to have a simplified cap table. So all of the people who have a stake in the company, they want it nice and clean and simple if the company is going to be acquired by someone later. But it's also very important to acknowledge everyone who might have contributed early on. Otherwise, there's going to be a fight later. Co-founder positions, nail this down, leave space to adapt, because things do change over time. The person who you thought was going to put all their effort into it disappears the next day. You need to be prepared for that sort of thing. Who makes the decisions? No right answer. Sometimes you'll have someone with a clear majority equity stake, sometimes not. So just like nailing this down, these things need to be stated. I'm someone who generally approaches things of, that worst case scenario is never going to happen. Don't worry about it. Let's focus on what we think is going to happen. And time again, I've been proven wrong. not necessarily worst case, but those surprising situations that you need to plan for early on, they do happen. And so it is really important to nail all of this. How to divide the equity? The best way to explain this is nobody will be happy, but try to make it so that everyone is equally unhappy. That's about it. Who and how to hire? So I have seen this where a company early on, they're growing from the first 3 people to the first 20 people. And they just hire everyone, the first ones that come along. And it is really, really important to treat that process seriously because the quality and productivity changes drastically depending on who gets hired in those early stages. And there's so many other factors, so don't treat that lightly. It's an easy thing for one to treat lightly when you've got 9 things to do and it's not your work. But it's so important to the growth of the company. And I know situations where they could have been far more successful early on if they had put that effort in. So who to invest and how to raise capital? One thing that often happens is whether it's acquisition or investment or something like that, you only have one who is interested. And that's a bad situation. So someone wants to invest in what you've done. Do you take their investment or not? Far, far better is person A wants to invest and person B wants to invest. You can see who gives you the better offer, or they can both go in together and offer you something appealing or so on. So if you're in this stage, be patient. Try to get more than one potential investor. It does work out much better. And the last point is there are the founding teams. There are, and often it's not the founder, the first CEO, the first management people coming in, and the first investors. Somebody is going to hate somebody else. I don't know who it will be, but there will be some disagreement, especially if things continue to grow. So just be prepared for it. Most people, I like to think, are nice and friendly, but even so, there will be disagreements, and you need to be prepared and hopefully have a way to deal with it. So I mentioned alternate routes to commercialization. I am aware of time. My perspective, not the only one, dissemination generates interest. So protect what you can, but publicize it, tell the world you've got a great technology, and hopefully they will come to you. So the tech is only part of it, even like the magic source within the tech is only part of it. You do want to protect that. I'm not saying don't. But the true assets are the team and the knowledge. You disclose your complicated audio idea. And sure enough, one of the big players could come along and with 3 years of effort and 3 engineers duplicate what you have done, and maybe it works properly, or they could just acquire you or license your technology. They'll probably go for one of the latter options. So it's usually okay to talk a lot about it. The value is in what you've achieved. The assets are in the team. Lastly, it's here on the slide. There is no single route to commercialization. It can be stressful. Don't let it be too stressful, and enjoy the journey. Thanks.
Anonymous asks, could Nemisindo be created using text-prompted compression of hundreds of thousands of labeled sound design examples, so-called multimodal AI?
So I didn't quite get the question.
No worries, I'm here. I'm here, in front of you, in the first row. Could Nemisindo be created using text-prompted compression of hundreds of thousands of labeled sound design examples, so-called multimodal AI?
Yeah, it certainly could. So, as mentioned, we didn't use a generative neural network approach because those generally are a bit more black box. Now, they can be supplemented using techniques like what's in DDSP, differential digital signal processing, to use that to sort of optimize a more signal-based approach. But we did what we did because it gives us the controls that we want. But we know this now. A few years back, it was a radical idea, but we know that people just want to say to a computer, give me a sound like that. Now, make it brighter, make it warmer. Here's a bit of video there. So we want a lot of intelligence under the hood, and that seems to be the way that we're going. So it's sort of the equivalent, I think, of mapping those controls, the sliders and faders, to what someone would say in order for the system to learn how to manipulate those controls. I think it could be done. The harder question to answer is, what are the biggest hurdles there? And even more so, when, how long it will take. We're really heading in that direction. I think the good answer to give to most AI-related questions, how long it will take, is always 5 years. Because that's long enough so no one in the room is going to be saying, oh, he said that just then, and it didn't happen. But soon enough so that people think, it's going to be within their near lifetimes.
Yeah, thanks for the great presentation. Hello, I'm here. Hey, how's it going? My question is more related to the sort of software development side of things, since we're many software developers here, and anecdotally speaking, and also a lot with sort of industry acquaintances, I've often heard that sort of early prototyping of research projects comes at the expense of having a potentially unscalable solution. I put that very, very diplomatically, more like a single header file, enjoy your meal. Would you recommend, when researchers have a sensible and a novel idea, to maybe put a bit more effort into designing their library at the expense of maybe losing a bit of momentum during the prototyping phase?
It's a really good question. I would say no, mainly because all of the researchers who work with me are so very, very different. And I would suggest people play to their strengths. So when they have an idea that they're working on that has clear commercial potential, then I'll have a chat with them. Do you want to take this on? And because of the stuff I've been involved in for a while, I now have a lot of researchers working with other academics, even sometimes other academics, basically pitching their idea to me for some feedback. And that's always nice. Small effort on my part, it's very useful to them. So it really depends. Ultimately, if someone is a PhD student, the goal is for them to get a PhD, which means a significant contribution to knowledge. So one researcher working with me, he thinks real time. He thinks live, everything is real time. He developed all of his new algorithms from the ground up real time. It was sample-based processing. There was none of this, I'll do an offline solution, then just sort of apply some frame-based processing and treat it as if it was live. And that was great. And it meant that the work could be taken in new directions. But I don't tell people you need to do a mock-up or you need to focus on the design. Some people, for instance, only work with graphical programming languages. And so there's sort of innately some user interface aspects already built into the development. One absolutely brilliant researcher working with me was extremely dyslexic. A panning control, you turned it all the way up to turn it to mono. And so, I'm not going to force the researcher to change in that aspect, but I am going to encourage them to do whatever they can do to do their great work. So I know that a lot of the work that we do has commercial potential. If they are interested, I will certainly encourage them to think along those lines, but it's up to them.
All right, thank you. Another round of applause.